In this mini tutorial, we're going to cover how to create a custom SELinux policy for your web service. We're going to have an example web service written in the Pyramid web framework. This example returns "we" each time you make a request to it. And what we want to show is that although the service works as expected when you run it manually, when you try to automate it as a system unit service, it will fail, and that is because of certain SELinux policy restrictions. So what we've just shown is that the web service behaves as expected when you run it manually. In order to create it as a system service, you need to create this unit file that tells systemd how to run your application. Systemd is useful because you can enable your app to run when the machine restarts, or if the service stops unexpectedly, for example. And here we see that we tried to start the app, but it failed. And in many cases, if you get strange errors when you try to run it automatically, it's usually because of SELinux, and right now SELinux is enforcing. If we change SELinux to be permissive, what will happen is that our application will still run, so it's running now, but any errors that it sees, it'll log into the audit log file. So we can see that our web service is running in the background using the systemd run service. However, any errors were logged in var log audit.log. So these are the kind of errors, and you can look at this to figure out what's going on. But luckily we also have this command called audit to allow that will specify the exact rules that will give permission to our service to run as a system service. What we're doing is that we created a module from those rules, and it's a good idea to review each rule before you approve it, because you want to make sure that those rules came specifically from your application and not some genuine security attempt on your machine. We can compile the text module into a binary module using check module. Then we'll build it using SEModule package, and then finally with SEModule install we will install it. And once we install it, then this custom SELinux policy is active even on machine reboot. Installing it takes a couple of seconds. So now just to review what we covered was we had a web service and we created an SELinux policy so that this service will run even while SELinux is enforcing. So we get the security of SELinux as well as a working web service. That's kind of what we're demonstrating right now, which is we restored the enforcing to be enforcing, and our web service is running. All of these commands are on a tutorial that we published on crosscompute.com, where you can publish your own interactive computational blog and publish small tools. There on this tutorial we also included an Ansible script for automating the installation of your custom SELinux policy. That's it for now, and see you next time. Bye bye.